This is TAU Unbound, the English language podcast of Tel Aviv University. Please welcome your host, Ido Aharoni, Tel Aviv University's graduate, member of the Board of Governors, lecturer, writer, and veteran diplomat.
Welcome to yet another episode of TAU Unbound. I'm Ido Aharoni, your host, and it is my great privilege and honor to host the Dean of the Faculty of Medicine at Tel Aviv University, Professor Keren Avraham. Welcome.
Thank you, and thanks for the invitation. One small correction, if I may. We have a new name now. And as I describe the faculty, it'll become clearer why. We're the Faculty of Medical and Health Sciences.
All right. Faculty of Health and Medical Sciences.
Medical and Health Sciences.
Medical and Health Sciences.
Right.
Okay, that's an important distinction, and which means that the name is up for grabs, right? If any of you would like to
Exactly.
put your name on the faculty.
We are looking for a name.
Yeah.
Exactly.
So that's actually a good thing. But you're a big superstar in this university. Let me just mention the fact that you're the first female to hold this position.
Yes, true.
It's a very central faculty when you look at the history of healthcare in Israel and particularly the practice of medicine. Tel Aviv University has been very central because of its location, because of the quality of the faculty, and so you're now the head, which by definition makes you one of the most important women in Israel.
Thank you.
And I think you were selected as one of the most important women by a leading publication in Israel. So, but before we discuss your academic work, your research, the faculty, let's talk about you.
Okay.
Tell us about your background, your upbringing, how you ended up doing what you're doing.
How I ended up in Israel.
Yes.
Okay. I was born in Canada, moved to the United States when I was 6. And then at the age of 7, my parents, who had originally from Israel, decided to give it another try. We came back here for a year and a half. And then after that, we went back to the United States, but I spent all my summers here. So I think that was when I really connected to this country. And when I was 21, I came to study here in my last year of college and decided I wanted to stay. I applied to graduate school, went to the Weizmann Institute. And at the age of 21, young and naive, I felt that there was more of a sense of purpose to living in Israel, and I still believe that. And I've never looked back.
And so your parents were Israelis that lived abroad?
Correct.
Or, okay.
Correct.
So
For 50 years.
Were they academics?
Yeah.
Or?
No, my father was an engineer. My mother was a very successful businesswoman. She's now living in Israel. And they, like many Israelis, decided to give it a chance abroad. I should say that my father's family is from Egypt, and they moved, some of them from Egypt directly to Canada. Others went through Israel. So, we're a country. We're a family that goes back and forth between continents.
So you have Egyptian roots.
I do.
Wow, that's quite a legacy because the Egyptian jewelry is very, very interesting.
Yeah, Alexandria.
And from Alexandria. Wow, that's even more interesting. I was just talking to a friend of mine who's a very famous doctor, Raymond Shinazi. He's from Alexandria. And so I'll have to make that connection. He likes...
With pleasure.
Yeah. So you came to Israel at the age of 21 and permanently settled here, and you've been here ever since.
Well, I did a postdoc at the National Cancer Institute after I did my PhD. That's really a rite of passage that you need to go through in order to get a faculty position. So in 1996, I took this position at Tel Aviv University. Hard to believe, but that's how long I've been here on faculty.
And your PhD was in what area?
In molecular genetics.
So which is what you're doing now?
Which is what I'm doing. I worked on a model for Down syndrome. And then in my postdoc, I decided I wanted to learn more about using models to study human genetic diseases. So I went to the National Cancer Institute. And then when I came back here, I started my lab focusing on hearing loss, hereditary hearing loss and deafness. And the idea was that I could really combine the knowledge that I had gained in studying models for human disease, as well as the very rich genetics in being able to study the populations here.
So before we talk about your academic work, let's talk about the faculty. So you were appointed the end of 2022?
Correct.
And so tell us about the faculty, the scope of the work, the structure, all the things that we need to know about this very central faculty.
Okay, so as the new name reflects, we're really a faculty of medical and health sciences. We have a school of medicine where we train students to become physicians, as well as a graduate school, very extensive graduate school that trains masters and PhDs in biomedical science. We then have a School of Health Professions that trains students in communication disorders, physical therapy, occupational therapy, and nursing, our largest school there. We have a School of Public Health, one of the finest in the world. And we have a School of Dental Medicine, which is one of the two schools of dental medicine in Israel.
What are the needs of the market?
Everyone, right? I don't have to tell you, health is a major core for everything, right? And so I don't think that there's an area that we're not lacking, whether it's physicians, nurses, speech therapists, occupational therapists, physical therapists, and biomedical scientists. I truly believe that this is the present and the future, not only of Israel, of the world. You can't have humanity, you can't have a culture, you can't have a country without a very strong basis for all of those parameters. And not only to, of course, take care of our health. Right.
There is no economy without health, which is something that I heard many times during COVID when people were talking about, the cost of a pandemic, and people were responding appropriately that there is no health, there is no economy without health. And especially
there's no people without health.
Exactly, especially when we all know that life expectancy is going to grow, even possibly within our lifetime. And people say that it's going to grow significantly, like never before in the history of humanity. And the question is, what kind of life these people are going to have, the people that will live to be 95, maybe my grandkids. What kind of life will they have in terms of their health? It's a big question.
Well, 95 is already happening. The question is what's going to be at 110, 120. I believe, I hope it'll happen in our lifetime, because I think it's going to happen. The key issue is the quality of life. It's not whether we can live longer, but what's going to happen during those years. There's a major emphasis now on the quality of life in longevity, which is why if we talk about the needs, and I can talk about many areas of medicine where there's a need, one of them is geriatrics, because we're realizing that the aging population is growing. We want them to be healthier, more active, and up until that very last day. So we're certainly in a position where we're not just dealing with the primary diseases, but also thinking about what happens when we're aging.
And so let's go back to the faculty. So can you describe a little bit? So you mentioned that there's training people to be physicians is only one aspect of it, which most people, when they think of School of, Faculty of Medical and Health Sciences, they think of, training doctors. But you're talking about a much wider, broader perspective of healthcare.
Yeah, we have about 5,500 students in the faculty. I think we're now at about 900 students who are training to become physicians, and the rest are all the other groups of students that I talk about. So this is really a very cohesive group. And in fact, one of our major emphasis is interprofessionalism, so that there is crosstalk and education and courses between medical students, nursing students, et cetera, so that once they're out in the field, they're better integrated in working together. And really what is the basis for all of this is the research that's being done, because in order to have the breakthroughs in health, in disease, drug discovery, regenerative medicine, and I can go on and on about the long list of where we need to be able to focus our emphasis on and be able to apply, the basis for that is what's being done in the lab day to day. Those students who are just grueling long days getting those experiments to work. But every once in a while there's a scientific breakthrough, and that can make all the difference. And we've seen so many of those here at the Faculty of Medical and Health Sciences.
And I'm assuming that you have also interactions with other departments that are not part of the faculty.
Absolutely.
In terms of the impact of their research.
Yeah, so our collaboration all across the university. In fact, I would say that our major advantage at Tel Aviv University is the multidisciplinary research that's being done. None of us can be in silos. We all have to work together. So whether it's between schools, across faculties, I think the Sagol School of Neuroscience is a beautiful example of that. I have 2 students in my lab from the Sagol School of Neuroscience, and they're in the Faculty of Medical and Health Sciences.
And I should mention that you're also you're the Dumont Chair of Research of Hearing Disorders at the Sagol School of Neuroscience, and also you're affiliated with the Safra Center for Bioinformatics.
Yes.
What is informatics?
Yeah. So bioinformatics is actually the crosstalk between biology and computer science. And in order to analyze the enormous amount of data that's being generated in our laboratories and worldwide, you need to be able to combine that data that's being generated in biology, in experiments that are done in the lab, and translate that information, be able to analyze it using computer tools. So bioinformatics is an absolute major requisite for being able to do almost any kind of biological research. That was recognized already many years ago. I have to say that Tel Aviv University was one of the first places, certainly in Israel, if not in the world, to recognize that. And then the Safra Center for Bioinformatics was started, which is actually, they have a master's program, a PhD program, and they distributed pretty much all across the campus and have done an enormous amount, and also interactions with clinicians and the hospitals. So it's a major fundamental part of being able to do research.
And obviously with the expected growth in computational capacities, which everybody's talking about with quantum computing and so on, that would become even more central.
Right. And AI, machine learning and artificial intelligence are part of that as well. So you talk about, again, we're talking about our interactions across the university. There are other centers at the university that are specializing in these areas. And I think, if I think of the student today, and there's so many choices of being able to combine computers, engineering, medicine, biology together. We've just in the last couple of years started a combined program where you can get a medical degree and an engineering degree, or a medical degree and a bioinformatics degree. And so I think that for the student who's really interested in a couple of different areas and is thinking of where medicine is going, there are a lot of really outstanding opportunities for them.
Let me ask you a question that is almost inevitable in such a conversation. You mentioned machine learning, robotics, and on the spectrum you have people that say, it's not going to have really a big impact. And then you have people that will say, well, it will absolutely change the future of healthcare practice. How, and if it is possible at all, do you prepare students for a world where machines will be able to diagnose and give medical opinions?
Okay. Well, first of all, it's already happening. Certainly in terms of going through the data, but at the end of the day, you need a human being to do that delivery. You need the human being to make that analysis. So when people are saying, "Oh, AI is going to replace doctors," I don't believe that. I think that it's going to be synergistic. I think there's going to be a lot of work together. I think we have to be careful about some of the potential dangers, and that's a whole other field. We've started here an initiative for ethics in medicine dealing with AI, so that's a major emphasis here at Tel Aviv University. So I don't think there's going to be any of that replacing that people talk about. But I think we're going to use it to a tremendous advantage. It's going to mean that diagnoses can be made much quicker, much more efficiently. And if we can not have to wait 8 months for a diagnosis or for some kind of an exam, and you can do it much quicker, then of course that's going to change everything with regards to health. So I see it only as an advantage. There's a lot of excitement. There's a lot of hype too. I think you have to kind of take some of that, pick it apart and what's real and what's not real. But so back to your question of how do you train the students, classes, courses, lectures, self-study. There's so much to learn, and we're working really hard to provide those tools. We're giving courses in AI. We're also making sure that students are learning about innovation, entrepreneurship. How can they take these tools and bring it to the next step, bring it into the clinic? So we're working on those aspects as well.
Now, I'd like to talk a little bit about your specific area of expertise. And before we started this recording, you mentioned you stressed to me that it's important that you understand that I don't treat deafness as a physician. I study the genetics of it. Now, I have an interest in this because I grew up. I was born in 1962, so I grew up with the father.
Oh, that was a very good year.
Very good year.
So was I.
Oh, okay. So, but you look much younger than I. So I grew up with a father who couldn't hear. I mean, he could hear a little bit. And the assumption in our family was that because my father was injured twice in 1948, and one time it was a landmine that exploded, that he lost his hearing as a result of the war because his body was also full of shrapnel.
It was in one ear or two?
So one ear completely couldn't hear, and the other one maybe 20%. This is something that we discovered later. And so I grew up with a father that would used to do like this with his ear, and I would yell into his ear for him to hear me. And there was a great deal of shame involved. He didn't want to have any device. And back in the 60s and 70s...
Yeah, they weren't quite as small as they are today.
Right.
Yeah.
And then only in the 1980s and 1990s he started to treat this. But then we discovered that he had a sister a little bit older than him who had the same problem. So it was not the war. It was hereditary. And I think in their case it had something to do with Sidan. How do you say Sidan? Calcium?
Calcium.
I think it had to do with I don't know, something with...
Autosclerosis, maybe?
Maybe. But
Okay.
but my father was legally...
Conductive over sensory neural hearing loss? Or we're getting a little too technical now?
I don't master the technicalities, but my father was definitely deaf, legally deaf, and I'm being actually mentioned of that. Almost every day people tell me that I'm too loud, and it's because of that.
So have you had a hearing test lately?
If I didn't have a hearing test, but I should, I guess. But my point is that we built a whole story that it's because of the war. It turned out it was hereditary.
Yeah. Well, you don't know that for sure. You have to, 2 is not proof. You have to actually prove it. And you could check it by genetics.
Well, both of them are gone.
Right. Okay. So, and we'll have to wait and see what happens with you. But their onset was probably earlier. But what we study, going back to the genetics of hearing loss, is the hundreds of genes that are responsible for hereditary hearing loss. So in 1997, the first gene was discovered called connexin 26. It's responsible for about 30 to 50% of children who are born with a hearing loss. But the rest of the population, it's a whole spectrum of genes. And we've discovered about over 50 of those genes in our laboratory. So in each family, there's a different gene. So there's some genes that are present in only 10 families worldwide, and then there's other genes that are present in tens of thousands of families. So for that reason, there's a lot of different forms of deafness. Each one is due to a different gene. And what our goal is to try to not only to understand the mechanism, to understand why when there's a change in the DNA, it leads to a change in the protein. It causes the entire cascade to fail and there's no hearing. Other than that, we're trying to figure out ways to actually find treatments and cures. And we're doing that using gene therapy. At the moment, we're doing it at the level of models. But already in the United States and in China, they've been successful in doing gene therapy for human forms of hearing loss.
If you could explain for the benefit of our audience that doesn't master the language, what is gene therapy?
Sure. So you actually take the gene that's missing in these individuals and you engineer it into a vehicle, which is something called AAV. It's a certain kind of virus, but we've taken out all the negative things about a virus. It only has the advantages. And we actually injected it into the inner ear. And that virus actually allows that piece of DNA to multiply itself and to function as if these individuals had a normal gene, not the defective gene. Now we do it in mice. As I said, for one particular gene in the United States and China, they've succeeded in doing it in humans. So it's just the beginning, but very promising. Now, one of the problems is that in hearing loss, mostly what happens is we lose the hair cells. These are little cells. We're born with about 16,000 in each ear. And once they die, either because of a genetic defect, because of aging, they don't have a way to regenerate themselves. What this does, so we have to get in before the damage occurs, which is why being able to do a genetic diagnosis and determine the cause of the hearing loss as early as possible is critical, because if we can do it early enough, then we can go in and do the gene therapy. Now, it's just in early days in humans, but there's a lot of work being done, and I think very promising work for the future.
Incredible. I mean, it sounds like science fiction. Now,
It was 10 years ago. Now it's not.
Can you educate us a little bit about the scope of the problem of deafness in Israel and outside of Israel, if you have any information on that?
Well, so worldwide, over 450 million people have, and it's considered to go up close to 1 billion in the next 20 years or so, have a disabling hearing loss. So it's a very big problem. It's estimated that between 50 to 60% of that is due to genetic reasons, which is why our goal is to try to figure out what's happening on a national level. Those individuals in Israel who have a hearing loss, to try to figure out what the genetic reason is. The more information we have, then the better. When the gene therapy is available, we'll be able to use it for those that are interested.
So if by 2050 global population is expected to be around 10 billion, what you're saying is between 5 to 10% of global population will have some issue with hearing.
Yeah, it depends on the age. In the Western world, about 1 in 1,000 children is born with a disabling hearing loss.
And what's the ratio between children and adults when it comes to hearing problems?
So it goes up with time. So again, 1 in 1,000 in newborns, and then it goes up. In the elderly population, it's already up probably about, I don't know, we know worldwide, but probably at 40% or so. I'm giving a guess.
Now, can your research also help people that are using devices? I remember that my father, when he finally started, when he overcame the shame, and he finally started using a device, it became very difficult for him to be in a noisy place, in a crowded room, because apparently machine hearing doesn't have the ability to select.
The cocktail effect, yes.
Yeah, the cocktail effect, exactly.
I'm starting to get it myself, by the way.
And
That's what happens when you're born in 1962.
It drove him crazy, so he used to turn it off because he just wanted to go back to his peace and quiet. And so is your research going to help us fix that, or is it possible to fix it?
Well, I think what we're discussing is that it's not going to replace in many times, both hearing aids and cochlear implants, which is used for more profound deafness, can really be very helpful for someone with a hearing loss, but they're not ideal. And so it might be that in the early years that the gene therapy will complement it, and then together it'll work better. Whether it'll replace, we really don't know yet. It's still too early to tell. And then again, there's so many different genes, it will take quite some time before we can tackle all of the genes in humans.
Well, I can talk to you about this for hours. As you notice, I'm very interested and curious about that because of my own personal history. But I wanted to thank you for taking the time to tell us about your incredible work at the faculty, your leadership. And of course, we'd like to ask you to give us the opportunity to invite you again in the near future and hear more about the incredible work that you do.
Okay. I will just add one thing. It is the basis for the future in Israel. And so we're working very hard to make sure that we can move forward that way.
And on behalf of all of us who are listening to you right now, whether on podcast or YouTube, thank you so much for all the work that you do.
Thank you.
And to our friends and viewers at home and listeners at home from Tel Aviv, goodbye until our next episode.